There's a bowling ball M1 with a momentum 20 kilogram meters per second that strikes a stationary bowling pin M2. The bowling ball and pin take off as shown above. What's the final momentum of the pin? All right, so with these collisions, we need to compare before the collision with after the collision. All right, and so for M1, we're going to call M1 the ball, and M2 will be the pin. And we have ball and pin. And what we're looking for is the momentum of the pin. All right, so in the x direction, we have the momentum for 1 in the x direction, and we have the momentum of 1 in the y direction. We have the momentum of the pin in the x direction, and we have the momentum of the pin in the y direction. And after the collision, we have the momentum of the ball final in the x direction and the momentum of the ball final in the y direction, and same thing with the pin. All right, so the momentum of the ball initially in the x direction was given as 20, and I'm just going to write the 20 because I don't really have room for the units. And the momentum for the ball initially, there is no momentum for the ball initially in the y direction, so we're going to say 0. And for the pin was stationary, so it had nothing in the x and nothing in the y. After the collision, the ball moved at 12 kilogram meters per second at a 60-degree angle. So in its x direction, we can determine that's the cosine, so we could say cosine of 60 times 12 is the x direction, and for the y direction, it would be sine 60 times 12. Now for the pin in the x and y direction, well, we don't have the angle. We really don't have anything, so we're just going to leave that as unknown. All right, so we can resolve that cosine 60 times 12, and let's just put that number up here. That's going to be 6, and the sine of 60 times 12, that's going to be 10.4. All right, so conservation in the x direction. So we're going to have P1x plus P2x, that's the initial, equals P1 prime x plus P2 prime x. In the y direction, we have P1y plus P2y equals P1y prime plus P2y prime. All right, so P1x is 20, P2x is 0, P1x prime is, we determined, was 6, and P2x prime was unknown. So we'll just leave that as P2 prime x. So we can actually solve for P2 prime x. And that's going to be equal to 14. Now let's see in the y direction. P1y is 0. P2y is 0. So we have 0 equals P1y prime Oh, P1, no, that was a mistake. P1y prime we said was 10.4 plus P2y prime. So solving for P2y, we're going to get negative 10.4. All right, so now we have P2 prime x in the, and that equals 14. And we have P2y prime is negative 10.4. So we can easily solve for the resultant momentum vector by using Pythagorean, and we would have the final momentum for 2 is going to equal the square root of 14 squared plus 10.4 squared. And when you do the little bit of math, we come out with 17.4 kilogram meters per second. So our momentum for P2, we solved and got 17.4 kilogram times meters per second. And we could also determine theta here by relating the opposite and adjacent. So we have tan theta equals opposite over adjacent. So theta would equal the inverse tangent of 0.74. So theta would equal inverse tan 0.74. Inverse tan 0.74, and that's going to equal 36.5 degrees below horizontal.